Hello guys and welcome back to my channel. In today's lecture, we will be going through logistic regression modeling, a comprehensive guide. Welcome. This presentation explores logistic regression, a fundamental technique in statistical modeling. We will delve into its applications, interpretations, and evaluation, highlighting the advantages and key concepts behind this powerful tool. Understanding the logistic regression equation. The core equation, logistic regression equation, predicts the probability of binary outcome using a sigmoid function to transform a linear combination of predictor variable. The equation takes the form of p is equals to 1 by 1 plus exponent minus b0 plus b1 into x1 plus till bn into xn, where p represents predicted probability. Sigmoid function. The sigmoid function or S-shaped function maps any input value to a probability between 0 and 1. It ensures that the model's output is always a valid probability. The function has a steep slope near the middle, making it sensitive to change in input values. Common assumption and diagnostics for logistic regression. First, linearity. The relationship between predictor variables and the log odds of the outcome should be linear. This assumption can be checked using scatterplot and residual analysis. Second, independence. Observations should be independent of each other. This assumption can be violated if there are repeated measures or if the observations are clustered. Multicollinearity predicts variables should not be highly correlated with each other. This assumption can be checked using variance inflation factor VIF. Now, performing logistic regression in Python. Like we have given an example. For example, Python from sklearn.linear underscore model import logistic regression model, which is equals to logistic regression function model lifit xy print model score and xy. This will print model score of x and y. Interpreting logistic regression result. Coefficients. Coefficient indicates the change in the log odds of the outcome for a 1 unit increase in the predictor variable. Positive coefficients indicates a positive association while negative coefficients indicates a negative association. Odd ratios. Odd ratios represents the change in order of the outcome from 1 unit increase in the predictor variable. An odd ratio greater than 1 indicates an increased order of the outcome, while an odd ratio less than 1 indicates a decreased order of the outcome. P-values. P-values indicate the probability of observing the observed result if the null hypothesis were true. A p-value less than 0.05 is generally considered statistically significant, suggesting evidence against the null hypothesis. Now, evaluating model performances. First, accuracy, second, precision, and third, recall. These all topics we have covered in our previous videos. So, I will give you link in the description. You can go and watch it. Now, for that, I will briefly cover these. First, accuracy, the proportion of correctly classified instances. Precision, the proportion of correctly classified positive instances among all instances classified as positive. Recall, the proportion of correctly classified positive instances among all actual positive instances. Now, Poisson regression, modeling count data. First, count data. Poisson regression is used to model count data, representing the number of events occurring within a specific time period or space. Assumption. The key assumption is that the mean and the variance of the count data are equal. This assumption can be checked by a variety of diagnostic tests. Application. Poisson regression is commonly used in healthcare insurance and financing to analyze events counts like hospital administration, stocks and trades, and insurance claim. Now, applying Poisson in Python. Python from statsmodel.formula.api import GLM model, which is GLM output predictor plus predictor 2. Here data is equals to data family, which is equals to sm dot families dot Poisson, which gives the result, and in result we will put model fit. Now we will print that result in the screen. Now, hello, this is the end of the video. If you liked the video, please subscribe and thank you.